the root mean square value, or RMS. So here in AC signal representation. Okay, so given a half cycle waveform, same with the average value. Okay, so RMS, or we call this one the root mean square value, tells us that it gives us a value that wherein the power of AC, or the alternating current, is equal to the power of the direct current. Okay, so how do you solve for the power of the direct current? So we know that power is equal to I squared R. Okay, now that current that gives the same amount of power with AC and DC is what we call the RMS value. Okay, so that current IRMS squared times R, okay, is equal to the integration of the power generated by the instantaneous value power, or instantaneous power, okay, of that signal. Okay, so we know that power is equal to I squared R. Okay, now this current here is the instantaneous current. Okay, so the instantaneous power is equal to the resistance times the square of the instantaneous current. Okay, so okay, from then we integrate this one from 0 to the period. Okay, so one full cycle. When you say T, so that's a full cycle. Here in this diagram we have a half cycle. Okay, so if you are dealing with a full cycle, so you have a one whole from 0 to 0. Okay, so this is what we call the period. Okay, time. Sorry, that's time. Okay, now we have seen the IRMS. Okay, and then we have here the finding IRMS, and we know that I of t, or the instantaneous current, can be expressed by a sinusoid. Here we have the sinusoid Im sine wt. Okay, and taking the square, and you notice we cancel out the current. Okay, so there's no current. We cancel out the resistance, so there's no resistance in the equation. And then if we try to solve this one, you will notice that the sine function will be equated into will be removed from the equation. Okay, so by just looking at the equation, so we know that the integration of sine squared, okay, that would be a certain value, and then if you evaluate that one from 0 to t, and that will become 1. Okay, actually that's what for the integration. So I'll give that one to you as an assignment, or I mean for you guys to discover. But the actual, or the result of this integration is 1 over square root of 2 Im. Okay, so then we have the IRMS is equal to 0.707 times the magnitude of the current in the sinusoid. Okay, so meaning we have IRMS greater than IAV, because IAV is 0.636 of the magnitude of the sinusoid, while the IRMS is 0.707. Okay, take note the difference. IRMS gives us the value that equates the power of AC with the power of DC, or the energy of AC to the energy of DC. Okay, now another term for RMS is what we call the effective value. So you might encounter this one in some of the problems. Okay, so we call this one effective value, or effective current, effective voltage of the AC circuit. Okay, that's it, the root mean square value.